Hi, hello everyone. I'm Jay Surya. Okay, in our last video, we are discussing what is the supervised learning, what is the classification problem, what is the regression problem, and what is the decision tree and important terminology of the decision tree and how will be decision tree work. Okay, these are all the things we are discussing in last video. Okay, I'd say in last video already I said and in our decision tree select the attribute. Okay, select the best attribute through the ASM method. Okay, so ASM method, what is the ASM method? ASM method is a attribution selection method. Okay, ASM is a attribution selection method. What is the attribution selection method means? It's provide the rank or provide the score of each and every features. Okay, through this score, which is the best score of attribute will be selected the splitting attribute. For example, suppose if your data set already we are discussing a loan risking data set. Okay, so suppose your data set column column loan amount or due due one due to and a balance amount. So these are our column names. Okay, so ASM given the score of each and every each and every attribute. Okay, so which attribute is the has highest score, that attribute will be splitting the data set. Okay, splitting the attribute. Okay, here for I assume loan amount is the highest score, so loan amount is here split in the data set or split in the attribute. Okay, so okay, let's prove on that. Okay, how can we achieve attribute selection method? Any methods available? Yeah, information gain, Gini index, Gini ratio, these three methods are available. Okay, here first of all I focus on the information gain. Okay, I focus on the information gain. Okay, what is the information gain? It is a statistical property. In the information gain means it is a statistical property. Okay, it is a statistical property. It's a statistical property. Okay, it's measure how well and good perform the given attribute. Separate the training data according to the target classifications. Okay, that means let's look at this example. Let's consider let's imagine to the we have three bags A B C or three boxes A B C. Okay, yeah, I want to ask one questions. You can easily describe these three boxes. Yeah, easily say B boxes you can easily describe because B boxes have only green balls. Okay, you can easily say B back or B boxes have only green balls. Okay, so it is a pure ball, pure back or pure box. It is a pure, and C box has a less impure. That means two green balls and two red balls. Okay, so it is a less impure. It's a less impure. Since followed by, you can look at the A balls, three green balls, two black balls, two red balls, one blue balls. In A back or A box have lot of information you can gather. Okay, through the A box because it is a more impure. More impure means here not purity ball. Purity box because you have given the more informations, three green balls, two black balls, two red balls, one blue balls, etc. Lot of informations available in the A box. Okay, it is the high information. So it is the and information gain where your information gain is high, that attribute will be selected. That attribute will be best selected. Okay, so okay, that attribute will be selected. Okay, that attribute will be selected. Okay, now you can easily say B is a pure, C is a less impure, A is a more impure, more impure. Okay, what is meant by impure? Impure. What is meant by impure? Before impure, I mean impure means is measure the impurity of data set. Which method you can achieve by the measure of impurity? It's a entropy. Before we are going discuss about the entropy, I will share some some terms of impurity. Okay, impurity is nothing but it's similar to this ball method. Okay, impurity is nothing but it's similar to this method. Suppose I consider these three boxes. Here I can say three red and two red and one red. one blue, one pink. Okay. Now, what is the information you got about these images? Let's look. Left, the left side boxes is a less information because similar to previous method, less information because all ball colors are same, all ball colors are red, and middle boxes are just few information, two red balls, one purple balls, and right corner boxes, two red color balls and one violet, one pink color balls. So right brown ball need maximum information as both number of the both color ball are same. Okay, informations mean is the measure of purity. Information means is measure of purity. Okay, information is a measure of purity. So left bowl is a pure node, right bowl is a more impure, middle bowl is a less impure. Okay, how we can measure this impurity? Low impure, more impure, or no impure node. How will we can achieve using entropy method? Using entropy. Next we are to see the entropy. Okay, entropy method. What is the entropy? Entropy is a measure the impurity of data set. Okay, in the information gains, it will be decreases the entropy. Information gain will be decrease the entropy. For example, I clear this diagram. Okay, entropy is entropy. Elements are similar. All the elements. If you have one box and in the box, all the elements are similar. Your entropy is zero. For example, I consider this round box. This round box, all color, all things, all elements are similar. All elements means all elements are pink color, pink. All elements are pink. So this your entropy will be zero. Okay, but suppose if the samples are equally divided, your entropy is maximum one. Equally divided, your entropy is maximum one. For example, let's consider the another box. This box fully, so assume A is B. A box is similar the all the elements. So I replaced the all the rose balls from third. Two balls are green, two balls are red, two balls are green, and two balls are red. I can replace. Okay, I can replace here. 30 two balls green, two balls are red. I will replace it. Here says this ball says your impure will be increased. Your impure will be increased, but your purity will be decreased. Purity will be decreased. At the same time, your entropy will be increased. That means I will show. I will tell. In A box, your entropy will be zero. In B box, all the elements are not similar. It's a different. So it is a your entropy will be high. Okay, and A ball is a purity, but B balls have no purity. So your purity will be decreased. Here purity will be high. A ball will be purity will be high. Okay, this is a entropy. And information gain, compute the difference between the before entropy and after average entropy. Okay, and that before we are seeing information gain, we are seeing difference between that. Mm, I will give the one formula for of the entropy. Entropy formula is minus P of log 2 and minus Q of log 2. The P and Q is a successful or failure trajectory. Okay, and the information gains compute the difference between the before entropy and the average of after entropy. That means formula of the information gain, entropy of parent node minus average of entropy in child node. Okay, this is a formula. Okay, how to steps calculate entropy will be split. First of all, calculate the entropy parent node. Parent, first of all, calculate the first of all, I change the pen color. Okay, calculate the entropy in parent node. Then calculate the entropy each and individual node. Each and individual node means each and individual subnodes also. Okay, this is a split of entropy. Okay, this is a split of entropy. Okay, here let's look at the sample example. Okay, I clear my diagram. Okay, I have 30 student samples. I have 30 student sample within 3 value. Okay, for example, totally I have 30 student sample in 3 columns. For example, your gender, male or female, and year. You are a second year UG or second year PG or third year UG, second, 2 or 3. Okay, and your score 9 to 10. This is my input. Okay, okay, I apply the decision tree. So in out of 30 students, 50 out of 30. In out of the 30, totally 30 students, 50 out of the 15 out of 30 students select the placement the campus interview in the lockdown time. Okay. Now I want to create a model who will place the job during the lockdown. Okay. 15 out of 30 students are placement in lockdown time. So now I want to create a model who will select job or who will placement in during a lockdown. So in this we need to segregate the students. Okay, for example, segregate students you can split. First of all, I will take the gender wise. Okay, so totally 30. Gender wise, male, female. Okay, totally 30. In female students, I think total 30. In totally 20 students are sorry, 20 students are female and 10 students are male. Okay, in 10 students, 5 students are placement. Okay, sorry. In 20 students, 12 students are placement. Okay, totally 30 students. In male 10, female 20. Okay, male 10, female 20. Okay, in 10 of the male, I can 5 out of 10 students are placed. In 12 out of 20, girls are placed in lockdown time. Okay, now it is the percentage. Female is of 12 by 20 into 100 is a 60 percentage of students are placement in girls, and 50 percentage of boys are placement in during lockdown time. Okay, this is here along with the gender wise. Okay, now I can split the class wise. That means year wise. Year wise mean if I'm year, second year or third year. Third year means third year PG or second year UG. Okay, second year, third year. In second year students, totally 14 students are second year and 16 students are third year. Okay, out of 14 students, 8 students are placed in during lockdown time. In 16 students, out of 9 students are placement in lockdown time. Now it is the percentage of approximate, I say 57 percentage. You say 56 percentage, 55. I say only approximately, not exactly. Okay, 56. Okay, this is the split the data. Now apply the entropy. I already say employee entropy formula minus P log 2 minus Q of log 2. Okay, here is the data is not similar. So our entropy must be 1. Okay, entropy must be 1. Okay, now first split and in gender. First the diagram. Okay, can I rough this? So I will split. Okay, I change the pen color. Okay, for split and gender wise. Gender wise in for female totally 20 students are female. In 20 students out of 12 students are placement. So 12 by 20. Log of 12 by 20. Remaining 8 students divided 8 divided by 20. In log of 8 by 20. Approximately, I will say this entropy is 0.93. Okay, this is a female. Similar to male. Approximately, I say male is a 0.72 or 0.71. I assume 0.72. Okay, here both together, both gender, male and female. Apply that. Totally 10 are male into 0.72 plus 20 students are girls, 20 by 30 plus that entropy is 0.93. Okay, here our information gain. Suppose our value is 0.86 something. I say approximately. Okay, now your entropy is 0.86 in gender. In gender wise, your entropy is 0.86. Okay, now apply information gain. Information gain means 1 minus 0.86 something. Okay, 1 minus 0.86. And just I will put the approximately, not exact answer, just approximately. Okay, the answer is 0.112. Similar to the apply this method in similar to the year wise your entropy and your information gain also. So here your information gain in year is 0.21. Okay, already I say which information is high, which information already I say which information is high, that will be select the split, that is that attribute will be select the data. So gender will be select the split in data. Okay, this is the information gain. Okay, now we are discussing what is the information, what is the attribute selection method and the information gain method. In information gain we can how will be measure impurity through the entropy method. What is the entropy and entropy formula, and how will be difference between the before entropy and after splitting average entropy through the information gain method. These all the things are discussed through this video. Okay, thank you so much.